to why this blue screen of death happened as part of the CrowdStrike incident in July of 2024. And here's how it applies. I'm going to draw the same diagram again, except this time I'm going to call this ring 1. And think of it like area 1 for the castle, the outside perimeter, but in a computer system it's referred to as ring 1. And then the operating system and the most critical functions are going to be running in a separate and more secure area called ring 0. And just like our analogy of the castle and area 1 and area 0, instead of a computer system, we have these similar areas. Except they're referred to as the most secure areas here is ring 0, and the less secure area or the outside perimeter here is referred to as ring 1. And here at ring 0, the operating system is handling core functions for the operating system itself. So when we have other applications such as Microsoft Office applications or other programs or browsers that we're running, they're running in ring 1. It's also referred to as user mode. So these little red boxes I'm going to refer to as applications. Think of them like user applications that are running in ring 1. Now, for those applications to work, they need resources. For example, they need to get to memory, or they may need to write to the disk, or they may need to write to the network or make requests from the network. So when those apps need resources, they're interacting and making those requests to the ring 0 components. And right here at ring 0, we have things like memory management and access to the hardware and all these super secure services that the operating system is in charge of. And that would also include things such as drivers. So when an application needs resources, it's making those requests, and then hopefully those requests are being granted back to the applications from the operating system. Another common term for ring 0 and ring 1 are kernel mode, and I'll match that in the same color here. And just think of kernel mode as the most secure area of the operating system that gets direct access to the hardware and resources. And again, that's where the operating system runs and drivers run in ring 0 or in kernel mode. And ring 1, where most applications run, that's referred to as user mode. So in parentheses, I'll just shout out ring 0 for kernel mode, and next to user mode, I'll go ahead and put ring 1 just as a reminder. Now, what's the benefit of having two of these different modes, kernel mode at ring 0 and user mode? Well, the benefit is if we have an application that goes sideways, it has a problem or an issue, hopefully we just want that application to die by itself and not take down the entire system. And that's normally the case with applications that are run in user mode. For example, let's imagine we're running our favorite network-based game on our computer. It's running in user mode in ring level 1 and it crashes. The intent is for just that application to crash because of its problem and not to take down the entire operating system and get a blue screen of death. So let me clean this up just a teeny bit and let's talk about why the Falcon application, well, let's take a look at what that is, why that from CrowdStrike caused the blue screen of death. CrowdStrike makes some software that runs on a Windows computer that helps to identify and prevent malware. So think of it like an anti-malware program on steroids. It's really, really efficient until it brings down the computer. But for the moment, let's just go ahead and label out that their product called Falcon. Again, think of Falcon like an antivirus or anti-malware software. And as far as the impact goes, the blue screen of death happened to individuals and computer systems where they were running the Falcon service from CrowdStrike. Now, the reason that the Falcon software caused the blue screen of death was because it had two things that were currently working at the same time. Number one, the Falcon software is running in kernel mode here at ring 0. So if there's a problem with the software and it ruins effectively the kernel, that's going to cause the blue screen of death instead of the computer still trying to continue, which if there's problems at ring 0 with access to memory, for example, two different programs right into the same memory space or walking on top of each other, the operating system is designed to halt instead of continuing, which could lead to further data corruption. So their code, the Falcon code, is being run as a device driver here at ring 0 in kernel mode. And there's probably some great reasons why they're doing that. One would be they want more access and direct access to make sure that their anti-malware and antivirus, etc. software is currently working correctly and able to go ahead and really catch everything that's trying to happen. And it's not like they just walked up and said, hey, can we do this with Microsoft? They went through a process called WHQL, which is an acronym for Windows Hardware Qualified Lab, and they were certified, which effectively means that Microsoft tested and worked with their software, validated it, and said, yep, you're good to go. We approve of this. And here's the rub. Even though the Falcon software was certified through WHQL, so let's go ahead and manage this as Falcon right here. So it's been certified, it's been signed by Microsoft that it's good to go. The underlying components of Falcon periodically get updates, and that's where the whole thing went south. So let's imagine the Falcon software itself has some subordinate files. Think of them like files that the Falcon software itself uses as part of its operation. And let's go ahead and put file 1 and file 2 and file 3. And so if they need to update some components of the Falcon driver, their software effectively, what they can do is update those files, and then they have an updated component as part of the Falcon software. And that's deployed to clients that are using this system from CrowdStrike called Falcon through dynamic updates. Well, even though the Falcon software was certified by Microsoft, in the event that they do an update and they have a corrupt or incorrect file that they're using as part of the Falcon software, because it's running in kernel mode at ring 0, if there's a problem with one of those supporting files that's being used by Falcon, that could and did cause a problem. As part of the update that happened on July 19th with these files that were being used by the Falcon driver, which again is their code running at ring 0 in kernel mode, it can be identified as C dash, then 5 zeros, 291 dash, and then some extension, which won't matter too much because it's this update that caused the problem. So to answer the question, why did this happen? Customer systems that were using CrowdStrike's Falcon software, when they got the dynamic update, the update had an incorrect file, and as a result, the incorrect file caused the application to fail, and because it was at ring 0 or kernel mode, that caused the blue screen of death.